Thank you for being here. This is another session of TMS Behind the Scenes. Today, I'm going to talk about database performance and especially with Postgres in the context of TMS business, of course, but I believe mostly we'll talk about Postgres here. And actually, the motivation for this session was that we had real problems with a real-world application running in production that we had performance issues on Amazon, and I want to share with you what happened and things we did to solve it, and maybe you can share some knowledge here. Maybe you know more than me about this, and we'll see how it goes. I didn't have time to prepare a poll here in the TMS Web Academy. So I will ask in the chat, please let me know what databases do you use. Everyone here use Postgres or a different database. It would be nice to know. So, okay, you know what we're talking about. MySQL, ElevateDB, Firebird. Nobody use Postgres? SQL Server, come on guys. Firebird. Thank you, Oli. Postgres. After today, maybe. All right. Arimate is here. I know you use Postgres. Okay. So let me share with you what happened and what we did to solve. In our server here, we use Amazon RDS. Amazon RDS is an Amazon Web Service from Amazon that is a managed database server for you in the cloud. So they have, here in the case, we have an instance of RDS Postgres, but they have Aurora DB, they have MySQL, and a few others. I believe there's Oracle and SQL Server as well. I'm not sure. But in this case, it's a Postgres instance that we use as a storage for an Exadata server that it's running on an EC2 here. Okay, we have several Exadata servers here. Let me try to not get lost on the lots of screens here. So we have this is an Exadata server, and I believe there are 3 more here. And anyway, there are several Exadata servers running here in a single T2 micro machine. So this is a very simple one, very cheap one with 1 gigabytes. And you see some services are running as a Windows service, but this one we ran here as a standalone application, so you can see the log. You can see that this is real. Okay, this is a software or a software as a service that is serving like around 17,000 users. So here's what those users. Here's what's happening. The requests being happening here in this specific server. As you saw, there are at least six Exadata servers, APIs, different APIs. We split that. So this is one of them. Is one server that handles the subscriptions of those users, the paid and free subscriptions. So we see requests here, and this is what you're having problems with the past couple of weeks. And there were several problems. The first one was with the RDS. Where we started, everything started to get slow in our Postgres server, and we began to investigate what was going on. So the Amazon RDS has some nice features for you to monitor it. First of all, you have our databases here. In this case, we have a single one for this software. And besides several things here, we have one monitoring dashboard here where we can see some parameters for the server. One of them is CPU use. This is in the last hour, but if you put here in the last 2 weeks, we can see that this is the last week, this is the week before the last. So week 1 and week 2, you can see that in week 1 we had real peaks of CPU use, 60%, 70%, and you can see those are our regular intervals. And then of course we solve it in this week. I'll show you in a minute what happened. But the first thing I want to show you is the database connections in the last 2 weeks. Actually, the problem happened before that, but you can see that before this time window here, we had the database connections fixed at 80, around 80. And this chart here is where we started to working on it. I believe this is a weekend, if I'm not wrong. Yeah, 4 November. You can make them, yeah, Thursday. Okay, Friday. Yeah, this is what the weekend. So we started checking here in the weekend. We working on it, and then now we can see that the database connections are better. So the first thing we noticed was the database connections, and we are starting to have problems with pool allocation. Maybe you that have used Xdata, you might have fallen in such an issue where cannot get database connection from the pool. This can happen for many reasons. One is just because your pool is under, that's the English word, under defined. You have a low size for the pool if you have high pressure on your server. But it can happen also because of slowness, because if you have 3 or 4 simultaneous connection to your server, but your server is taking too much time to respond, that connection will get stuck, and another request comes, and the pool will end. Also, not because you have too many requests per second, but because your requests take too long. At the start, we didn't know what happened, what exactly was happening, but we see lots of connection there. Sorry. And we decided to investigate why there were so many connections. And so there were several reasons. One was logic on our application that we solved it. So our code was taking too many connections for one hour in a single request. Sometimes 2 or 3 connections were taken. And we also have 2 databases actually. So you have one instance of Postgres, but you have several databases in that instance. So we had, and that connection, that many connections we are taking, was in one database, in another database. So if you add up several servers, we have several Xdata servers connecting to several, with each Xdata server having its own pool, connecting to several databases in Postgres. So you multiply that, and so you had too many connections. Maybe that's what you need. Maybe in your application you have to use that many connections, but we knew that was not the case here, and we wanted to keep our server small. Again, this is an RDS server that is running with 1 gigabytes of memory. So one simple solution and temporary solution will just be, okay, let's increase the memory of this Postgres server to 2 or 4, increase the CPUs, and you're good in 15 minutes. But that's not the case. We want to have our server optimized and save money, of course, because if our customers increase double the next month, we still have to increase the Postgres server requirements. So the correct approach is to reduce the size. So the interesting part here is that this brought a couple of new Xdata features for the pool that I want to show you. Is that, well, I just want to mention for you. The first one is that you can now get the number of live connections from the pool. Okay. So we have a database connection here. Connection pool, actually. So if you have a pool running, you can have the database connection pool 1, that pool interface. Yeah, now you have this connection count where you can see how many connections are actually alive in the pool. So if you have a pool of size 20, for example, but the maximum size is 20, but you want to know how many of those 20 connections are actually taken and alive, even taken or waiting to be taken by the server. So we use this connection count. That was useful for us to debug, and it's a feature that will be available for you. Actually, probably in the metrics, so you'll be able to get the number of connections of the pool, the number of allocated connections, maybe average time between connections and things like that. So this is a very nice feature coming that was useful for us and might be useful for you. And another one, which is even nicer, is that in the connection pool here, you have this cleanup timeout, which is 0 by default to not break backward compatibility. But if I put a value here of milliseconds, I don't remember if it's milliseconds or seconds, but I believe it's milliseconds. It will destroy, dispose the connections that has not been used for this amount of time. Okay, because that's the reason we have 80 connections there. One of the reasons, it's because, for example, your pool is a size 0, and then suddenly you have 10 connections to your server at the same time. So the server will create 10 connections to the Postgres database or whatever database you use. And after those connections end, we start having, for example, then 1 connection per second. Those 10 Postgres connections will stay there to be reused for performance, which is nice, which is the purpose of the pool. But if then that peak of 10 simultaneous connections was just something out of the curve, and you have your server now for 1 hour receives almost no connection, those 10 connections will still be there waiting to be used in the previous version, in the current version you have. So if you want, you can set up a timeout here so that the pool will destroy those connections after they have not been used for 10 minutes or 15 minutes or 5 minutes or 1 hour. Okay, so that's why actually you now have a chart like this. We have a chart like this in our RDS. You can see that we have stable connections here. These were tests, but before we have stable connections because the connections were never released, which was not a problem actually. But now you see that the connections varies here because if the server has increased the number of connections, your API server, it after some time released the database connections in the pool. Okay. So we never reached the 80 connections anymore. It's just in the range of 20 connections, or even here we did another improvement here at this point, not related to Xdata, but now the average it's like 9 or 10 connections for all those servers there, right? Any comments about these parts? Comments, questions about this database pool mechanism and the Postgre and things like that? Are you there? All right. So the other problem was CPU. That was crazy. Okay. And that was actually the main reason why the server was slow. The connections were not much a problem. The only problem with the connections was that there is a limit for the number of connections that our server can reach because of the server is small. The hardware server is small. It's one vCPU. Mind you, the Postgres server we are running here is one vCPU with 1 gigabytes of memory. And you can see that it's receiving requests all the time. It's very, I will not say heavy because it requires a very small hardware, but it's heavy enough for us to have to optimize it to continue using this server here. So we are picking high CPU and slowness, and because of the slowness, we had errors of connections not being able to get the pool and requests. There was actually chaotic with the customers. So how did you solve this? The RDS itself has a feature here for you to analyze what's going on regarding performance. This is in this performance insights here that you have to previously enable in your server. Okay, I believe, let me go there. I believe you have to go here. If I remember correctly, you have to select your instance and configuration here. Modify, I guess. This is all production, okay, guys? Don't make me do some mistake here. That's why it's slow. Okay. Here, you have to enable performance insights. So it gives you a default of 7 days, which is free. And then if you want more, like 2 years, then there is a fee for you to pay. In this case here, it was just 7 days is enough. It's not enough for you to show you what happened because we only have 7 days here, but that'll be fine. So we have this performance insights feature here that you can see data from the last 5 minutes or 1 hour or 5 hours or maximum 1 week or maximum, which will be 2 weeks in our case, or 1 year if you want to run it. And then we can see here, let me put 1 week here. I believe you do not get the issues we had. Yeah, there is a peak here. 1 week we can see a peak of it's not CPU, it's called average active sessions. But if you take this chart here at the time we were working, we had a craziness of Arimate is here. Maybe he can paste in our private chat here one screenshot of how it was like It was just crazy. This dashed line here is the limits for your server. We are reaching like 15 or 20 more times the limit of our server. So this chart is already useful for you to see if your server is under, what's the word, English name, under defined, under designed, under, you have low specifications for your server, so you have to increase your server. And because it also shows you if the slowness or the overload in your server is the CPU or is the disk or whatever. There are several mechanisms here that you can see, or log file, to see what is loading up your server with work. And there is also a nice some nice metrics here for you to see what are the top hosts that are taking server resources. In this case here, there is only one. The applications, yeah, the applications is nice to see. Yeah, you can see here that Fatur server is taking the most of the server, but it's slow now. So you have the applications that are performing more SQL statements or more communication with the server that it's causing problems with your server. And also the top databases. As I said, we also have many databases here. You can see the database that is causing more problems. Again, it's the Fatur one, which is the database that is accessed by the Fatur application. And you have these top SQL statements here. Which we use it the most, to see the top SQL statements that are causing delays, slow. So this is what you did with check. We were able to see what were the SQL statements that were causing more issues here. Okay, and then we started to optimize those SQL statements. Some questions here. Why not run your own monitoring? Well, because what do we mean by our own monitoring? We had this option here. It's free. We are already paying for RDS, so it's free. But of course, there are other mechanisms. I'll show you actually what we did manually. But I'll be happy if you can suggest something better or different. Monitor everything. Yeah, what do you suggest? Software. What we did, I will show in a minute, was to use some SQL statements. We enabled some stats in Postgres, so you can check in details what the SQL statements were. Is this only for one database? No, it's for the server, as you saw. So it's for all the databases in this server instance. Okay. All right. So we started optimizing here. As Benno said, we also use it with this some SQL statements to directly in the PG stats extension. So in Postgres, let me change it here. Too many windows. All right, this one. This is I'm using PG admin to connect to the Postgres instance. And it gives us some stats here. And we have enabled the pgstats extension. And with that, we can perform several low-level SQL statements to the server so that we can check what's going on. Sorry, guys, my computer is slow here, especially when I'm streaming for you, because it takes some CPU. So this is some SQL statement, for example, to retrieve the similar status of the one that RDS gives to me, which is the connections to the Postgres server. This was an interesting one. So we could see how many connections were open from each application that we are running. This is related to when we are trying to optimize the connection pool. So we noticed that at the time that one or two applications here had a lot of connections open, like 10 or 15, and the others had one. So that way we could identify some logic problems in the application, as I told you, that we are taking too many database connections for a simple request. And another very interesting one is this SQL statement here, which give us exactly the SQL statements that takes more time to execute. We can take the SQL statements that takes more time to execute, or the SQL statements that were more executed. So maybe there is one SQL statement that is not that slow, but it executed 2,000 times in your application. So you can see that here to see if you have a bottleneck, if you have some wrong logic there. And from here, we could better analyze which of the SQL statements were slow, and we started optimize it. So it was very interesting because some of SQL statements were talking about the Aurelius query that caused a slow statement, not because Aurelius generated a wrong statement, but because the query was complex anyway. And third, we had SQL statements, we had SQL statements that were slow and we need them, and then we had to optimize them. I believe some of you know Benno is an expert in Postgres, so he knows this for sure. But so we can take, for example, one SQL statement here. And we can ask Postgres to generate a query plan for us. Yeah, I have to change some. The SQL statements had parameters. I have to this has 9 parameters, so never mind. But it gives you. Let me write a simple one here. Select ID from subscriptions where yeah, this is a query plan here. Let me try to find a field here. Columns. subscription where trial started. Archive equals ft. Yeah, so it shows you what the algorithms of Postgres. You have this in all databases, of course, most databases you use. It shows the algorithm that Postgres uses to build this query, to execute this query. And you can see that there is a sexcan here that indicates that this search here is not will not be executed very optimized. This is hard for newcomers to understand this query plan here, but there is a nice, had slow SQL statements in your server, okay? Then we executed some SQL statements to get the slow SQL statements. I believe you have to execute this. This one, okay? I'll keep an eye here more on the webinar window. So this SQL statement here, it brings us with the slowest SQL statements that has been executed since we reset the server statics. Okay, so what did you do? We reset the stats of the server with a special SQL statement, and then we ran the processes that were slow, that were causing the server to be slow. And then after a while, we executed this SQL statement here to see during that process what were the SQL statements that took more time from the server. And then we have a list like this. I'm not sure if you heard me saying that, but there were several reasons for the SQL statements to be here. One of them is that we had wrong logic in our application. We are calling too many SQL statements that were needed. Another one was that we had some slow, complex statements being executed, but and then we try to refactor our code to avoid those complex statements and change the logic to maybe execute more simple statements or things like that. We just detected, for example, that we were bringing lists that were not needed, so we just refactored in our code. And finally, we had statements that had to be executed but were slow, okay? And in those cases, we used the query plan feature of Postgres, which show us the algorithm that Postgres is using. So this is what I was trying to show you. So this is just an example. Suppose that one of the SQL statements in the list below there was this SQL statement here, okay? And then this SQL statement was slow. Then we call explain analyze and pass the SQL statement. And Postgres will give us the algorithm that it's using to execute that statement. Sorry. Here. So it shows us the full algorithm that Postgres will use to execute that statement and bring the SQL to us. So in this case here, we can see that it's doing a sequential scan because it's trying to filter out what are the rows that match this condition. And then it gives us an estimate of the time and the effort. It's not trivial to understand this query plan here, but there are nice tools over there that help us So for example, if I Google for, huh? Oh my. You are seeing a Google page here with Postgres Query Plan Analyzer, right? That's not what I see here. Crazy. Let me try to fix it. 1 minute. Okay. Here. There's something wrong here with my, okay. This is low as hell. So I can paste that query plan here. If I was able to do so. Not being able to copy this. Yeah. Well, these technical problems are causing issues here. Anyway, you can use this site here to have a better, this is just an execute a query pen for another person. So you can copy and paste these parts here, and you can see all the algorithm here that Postgres use, and the reds, it shows you the bottlenecks in the red and orange and yellow parts. So you can try to understand what's going on here and optimize your query. Maybe it's a left join. In our case, it was actually, the solution was simple. We are just doing some queries that over filtering by some fields that we didn't have indexes for it. So we created the indexes, and the query was fast again. Okay. But let me know if you have some questions. Let's discuss a little bit here. We have 5 or 10 minutes if you have questions about this. As I said, what I wanted to share was our experience, our real experience we had in the couple of past weeks, and show you, that's why it's called behind the scenes, show you what we did to solve it, the tools we use it, the improvements that we made to Xdata, actually, to Sparkle, to help us, that you might benefit from it, and share the experience we had. Okay, there is a question here from Emin. Do you make statement caching for parameterized queries? In the past, I have seen performance increase with statement caching. I'm not sure if this is done by the database itself in nowadays. Well, we have statement preparing, right? You can prepare a statement in advance and execute it. In the case we are using Aurelius, it happens when you have batch If you use the batch feature, for example, you are inserting or deleting or updating lots of records. It's useful, and Aurelius provides it. Okay, by statement caching, what do we mean then? Okay, what's the difference between statement caching and preparing? Oh, no, we don't use that. I know what you mean. Uh, it, maybe it should be possible to use it here, but you have to take into account that this is a server. Do you use that in a Java server? Because if you keep the statement open, you start adding states to your server, right? And how are you going to reuse it in different requests and things like that? So by no, you mean no server? Okay. Dimitris is asking which framework is better in performance. You mean FireDAC, UniDAC, Zeus? That's what you mean? Uh, we didn't perform a heavy benchmark of it, actually, because it's different from different databases, I believe. For example, it's not real statement, but FireDAC might be faster with Firebird, and UniDAC might be faster with SQL Server. What we did, what Aurelius provides the native Microsoft SQL Server, and in that case, we benchmark it and we try to optimize it. So I can say it's faster than FireDAC and UniDAC in most cases, because of course it should be like that, because it's tuned to work with Aurelius. But for Postgres, I don't know, actually, to be honest with you. In general, FireDAC and UniDAC are very similar. I didn't find any. We benchmark from here and there, and I didn't find a difference in performance in both, actually. So keeping statement objects in a list attached to pulled connection, and on next hit, it checked if it has this prepared statement ready. Yeah, but that's a prepared statement, isn't it? I mean, you are caching prepared statements. That's what you mean? You have prepared some statements and you keep them cached to reuse them. It's possible. It's caching the data set, right? The prepared statement. That's what you mean. Caching the prepared statement. The data set or some handle to the database client that holds a prepared statement, right? Yeah, the prepared statement. You cache the prepared statement. There's not a built-in mechanism for that. You can do that, but unless you have a very heavy use of SQL statement and you realize that the prepared statement improves performance, you might. That's too low level and too fine tuning. I believe, just for very specific reasons, in my opinion, because you add complexity and you add memory use to your server, and you might add bugs, right? Have you used pull lists of connection using non-blocking lists? Have used pull lists of connection using non-blocking lists. Sorry, I didn't understand that, Dimitris. Statement caching improves performance by caching executable statements that are used repeatedly. Yes, such as in a loop or in a method that's called. Well, that's I understand that as prepared statement. If you're using in a loop, you can use a prepared statements. But that's not the case here. Especially in the server, you're not reusing things unless, as said, you start adding states to your server, and then you have to manage that. It's possible, that, but you have to manage that. Hey, Eduardo. Are you stalking me with your eyes? All right, guys, any more questions or clarifications? Suggestions? Constructive criticism? Besides the problem we had with the... Sure. Feel free to send via email or our support center. It's open there. You can send suggestions there. Taking a connection from the pool is the pool non-blocking. Yes, it's non-blocking. Using non-blocking CPU instructions. Well, we have threads synchronization to avoid. This is just slow implementation, right? The pool is fast. We use semaphores. We use thread synchronization mechanisms to be sure that we can get the right connection from the pool. Is that your question? And you can see the implementation in the units sparkle sys object pool.pass. You have the source code also. You can send questions via support center as well if you want to discuss. But you can see the source code yourself, sparkle.sys.objectpool.pass. All right, guys, any more questions? It looks like it was recording. So hopefully we have a recorded version of this. We'll cut out the minutes I was in complete silence. Thank you guys for being with me today. Feel free to, don't forget to subscribe to our, let me put the link again here for you. Have you subscribed to the topic there behind the scenes? You get email notifications about it for the upcoming, this one. For the upcoming webinars, if you go there, you click the button below. There is a button there to watch or something like that. So you receive notifications about everything that is every new webinar that we release, for you to register, news about this behind the scenes series when we have replays. So everything is announced there. So just subscribe and you'll be fine for the next webinars and replays. All right. Thank you again. Sorry for the trouble today, and see you next time.